All right, so let's take a look at the whole code and let's see if we can figure out why Prado's code is not working. All right, so first of all, I'll take it from the top, I guess. Point cloud, and you read in a point, and let's start off by reformatting your code. Why are your tabs so big, my man? Your tab stop is set to 8. 8. There. One space indentation. There we go. Let's go. Let's do this. All right. Color scheme Elflord. There we go. All right. So this is going to be a collection of all the different points. You are successfully reading all of the points using the read library, which makes it really nice, doesn't it? It really does. So it reads all the points in. If X and Y are both 0, then it prints hyper combo finish for some reason. And then otherwise it will break. So yeah, you don't need this else. The reason why you don't need the else is because if this if statement is taken, it breaks out of the loop. And so it'll skip over there anyway. So you don't usually need an else following a return or a break or a continue, because those things aren't going to proceed downwards anyway. So this is a pro tip. Grub box is nice. Yeah. I like solarized. Do I have this on here? Color scheme solarized. Do I have it? No, not for you guys, just for me. Okay. All right. So you start off with an empty hole, and that shouldn't be there. It should be there. And that else statement isn't needed. And so we'll delete the matching else brace, reformat, hop back down. All right. What's going on here? Okay, whatever. All right, so let's take a look at this. So, so you're going through every point in the point cloud for every other point in the point cloud, and that's what this is doing. It's saying it has to be a different point. So for every pair of points in both directions, it's going to compare. It's going to look at them. It's going to start off by saying how many people are on the other side of me, one side of me. And then you're saying for every point in the point cloud, it's going to cross product point cloud I, point cloud J, point cloud K. And so this is going to compare a vector from I to J and a vector from I to K, and it's going to return a number from 1 to -1, depending on if I to K is to the right or if I to K is to the left of I to J. So this is linear algebra at its finest. It doesn't return -1. No, it doesn't return -1. It returns a negative number. So if the answer is less than 0, that'll be on the right-hand side. And so what you're doing here now is you're counting every point that is to the right of I to J. And if all of the points are to the right, this if statement doesn't belong here. So basically, yes. Okay. So for all of the points, so you have a line, right? And you want to see if all of the points are to the right of the line. And so the line I to J, you want to see if all points K are to the right of it. First of all, if one thing you do need to do is say if K is equal to I or K is equal to J. Right, because right now, I think you're going to get hosed by the fact that the line itself is maybe sometimes to the right, maybe sometimes to the left, rounding errors. That might be why you're getting random answers, is because you're comparing the line with itself. So if it's ourself, then let's just say it's cool, we're cool with it. Let's fine. It passes the test. And continue on our merry way. Okay. So we're going to point cloud from I to j and from I to k. Point cloud. We're going to dot product, a cross product from I to j and I to k. And if the answer is negative, that means it's to the right. And so if the answer is negative, it's to the right. That point is to the right. We increase other size by 1. And then if other size equals other size or other size minus 1. Yeah, that's probably why you're messing with that. Because the point being collinear with itself oftentimes won't be exactly equal because it's floating point, and floating point is full of error. So maybe set other size to 0 in here. No, maybe, but no. Okay, so if other size equals size, so that if all of the points are to the right, or us, then add that to the whole. Okay, and so this is what we were talking about in 41 today, which is that you can create an anonymous variable. So anytime you pass something to a function, and that function takes a class, in this case it takes a line. A line has a constructor where it takes 2 points. You can just pass 2 points to it. 2 points to it wrapped in the universal initialization syntax like that. You can pass 2 points to it, and it'll actually make a new line for you, and then copy that into the whole. A better way of doing this would be using inplaceback. Inplaceback doesn't, because what you're doing right now is you're creating a temporary variable with no name of type line that has point I and point j in it, and then once that's built, then it copies that into the vector. And you can actually get around that by using inplaceback. Inplaceback will not create the temporary. And so that'll actually make a new element in the vector and then copy the points into that directly without making a temp and then copying from the temp into the vector. So inplaceback in this case would be the better solution if we were pressed for CPU time, which we're not. This algorithm's order n cubed. It's already bad. You know, the use of inplaceback is not going to really be noticeable. There are much better algorithms than this, by the way. I posted on the chat channel, there's Graham's algorithm, and there's the gift wrapping algorithm, and then there's one that like combines the two. Like I said, there's a lot of different ways of creating holes. This is the most basic, and I always like to start with the most basic version of things and work my way up from there. Gift wrapping is order n times h, yeah, where h is the number of points in the hole, yeah, which is nice. So if you have a lot of points but not many on the hole, the gift wrapping algorithm is actually very, very fast. And then Graham's algorithm, I think, is order n log n, something like that, or n squared, something like that. Yeah. Either way, it's much better than this algorithm here, which is garbage slow, but it's simple to wrap your mind around. Okay, so this should do it. Let's see how we're doing on the inplaceback. Nope, didn't like it. All right, whatever. We'll switch back to pushback. Okay, make it. Your tabs are getting bigger. The tabs are getting bigger every time.
Oh wait, no. Does the line have an explicit constructor?
No. I don't think so.
And I think you need, don't you need one to call inplaceback?
Yeah, whatever. I don't care. The performance of this isn't going to hurt us right now, but yeah. as a note for the future, in situations like this, where you're constructing a object that has a lot of member variables in it, and then you're immediately copying into that, and then you're copying from it, just use inplaceback, because inplaceback will copy directly into the vector instead of making a temp and then copying the temp. But here, who cares? We're already garbage slow with our triply nested for loop. Right. Okay, so let's get this compiled. Okay, run it. So 1 1 2 2 1 1 2 2 1 3 and 0 1. So we're making a diamond, right? And there we go. It worked. Okay. And so the bounding circle is the center point of this is going to be 0.5. No, that's wrong. The is it wrong? I don't know. What 2 points are the furthest away from each other? Probably 0, 1, 2, 3. One, two, three. Oh, there's actually different options. Yeah, actually, I could see that. I could see, yeah, because there's 2 people that are the same length apart. Either way. So radius of that, and then let's see if 1.5 is in the middle. Nope. So he hasn't done his whole testing either. Okay. So, okay. I'm sorry. Copy.vimrc to proto vimrc. Cannot stat vimrc. You don't have a vimrc? Well, there's your problem. There we go. Much nicer. Okay. Graham's algorithm and Graham's scan different. No, it's the same thing. Yeah, basically when you do a Graham scan, it you sort the points left to right or top to bottom. It doesn't really matter which. You just sort the points on one of the axes, and then you pull the one, let's say on the far left, and then you add to the whole the next point to the right, and then that's what you start with. And then you add the next point, attach that point, and you see if the thing makes a left-hand turn. If it makes a left-hand turn, then you erase the point before it and connect those 2 points. And you do that until you reach the end. And what happens is you end up constructing a hole of the top half of it. Then you do it again on the bottom side, and delete all lines that result in right-hand turns. And then you end up with a top hole and a bottom hole. And you combine the 2 together, you get a full hole. And it's very fast. The sorting is in login, and then it's just order in time to do the top, in time to do the bottom. At most, you delete in elements only once. So yeah, it's an in login algorithm. It uses a stack. Yeah, you keep a stack of all the last things. And so what you do is you always just look at the last 3 points, and if they curve left for the top half, then you delete the midpoint. So if it's like this, and it curves left like it is, you delete the midpoint and just connect these 2. But now you have to do it again because that might be a left curve. And so you keep running backwards, and if you ever find a left-hand curve, you delete the midpoint and just connect the 2. And the thing is, each point can only be deleted once, and so it sounds like an n-squared algorithm, because for every point you might possibly have to go all the way back to the start and delete all of them. But once something's deleted, it's gone. You can't do that again. So every point in the hole can only be deleted once. And so it's actually an order in login algorithm for that reason. So, I was thinking about doing it that way, and in fact, that's why the output is sorted, because originally I was going to do it that way, but then I was just like, nah, whatever. I don't want to explode their heads. It's complicated enough. This is not. Whatever. And then gift wrapping, you basically sweep kind of a line around until you find the first. You kind of take the angle to all the different points, and then you find the one that is closest counterclockwise to you, and then you repeat. And so if all of the points are on the hole, then it's an order n squared algorithm, right? Because what you do is you just basically take the angle from you to all the people. You find the one that has the shallowest angle counterclockwise, and add that to the hole, and you just repeat. You keep doing that. So it could be an order n squared algorithm, but if there's a lot of points on the inside of the cloud, then each time you do this, it's only n points, so it's n times h. And so it depends on what your point cloud looks like. Sometimes Graham scan is better, sometimes gift wrapping is better, and then there's some genius came out with a version that combined the 2 for even better performance. So I think it's like h login or something like that. So yeah. Is this recorded? I hope so. I hope so. Hey, the alarm's going off, girl. Yes, it is recording right now. And it is also going to be saved on your account, Prado, so you can get your points. All right, so here we go. 4 says so you are finding. How did you do the bounding circle? So you found the people with. Okay, so you're just finding the 2 people with the. Oh, I see. Yeah, this is not right, I don't think. What you're supposed to do is find the distance from every point in the hole to every other point in the hole, and take the one that has the longest distance. What you're doing is you're just finding the line in the hole that has the longest distance. Hey, to turn off the alarm, please. Yeah, so you're finding the line that has the biggest distance. But what we're trying to do is find the center point, so to speak, of the polygon. Or find the longest diagonal within the polygon, so that would require a doubly nested for loop. And so for every point in the hole, for every other point in the hole, take the distance, keep the longest distance, wrap a circle around it like this, and then test to see. Okay, so before the end of the game, so please enter a point. Okay, so if you type 00, it quits. Otherwise, for every line in the hole. So this test here. Okay, so Prado, the whole reason why we did a bounding circle is because we don't want to do an order n operation when we don't have to. The whole reason why I don't really care about the order n cubed operation up top, or Graham's algorithm or any of that stuff, is because essentially what we're doing is we're pre-processing the hole. And so what we're doing is what's very common in video games, which is you construct at, design time a hole, and then that hole gets saved. And so, the amount of time you spend making the holes doesn't really matter. I would still not use this in real life. I would use GramScan or gift wrapping. But I'm not super concerned about it, because what we care about is that at runtime, when you're playing a game, you need to get your maximum frame rate up. And so what you have right here is an order n algorithm. And so it's going to go through every line in the hole and see if it's not within the circle, and it's not equal to the starting point, it's not equal to the ending point. And you're gonna do this over and over again. The whole point of having a bounding circle is that it's a very fast test to see if a point is within a circle, right? Like we talked about last time, you don't even have to do a square root for that, right? And so what I would do is pull the circle test out. So if it is not, all you have to do is say if it is not within the circle. If it's not within the circle, point is outside the bounding circle, and continue, right? So if the point is not within the bounding circle, which is a fast test, all you have to do is square the distance and square the radius and compare the squares, right? Do you guys understand why that works? Like if you have, normally Pythagoras is square root of a squared and plus b squared. But if what you're doing is a comparison between 2 different square roots, right? Like if what you're doing is the comparison of 2 different square roots, you can actually just square both sides. And, you know what I mean? And save yourself the square root, because the square root is the most expensive part of that equation. You can double something pretty quickly. So you can just compare the square of the radius with the square of the distance from the point is from the center of the sphere. It's a fast test. And then you don't have to do an order n operation at all. You just are done. If it's outside of the bounding circle, you're done. And this is a very common optimization. So when we do collision detection, a lot of times we'll just wrap a sphere around a Quake soldier or a capsule or a bounding box, something like that, because doing these intersection tests are super easy. Like a rectangle's really easy, right? If you want to see if something's inside of a rectangle, is x bigger than the minimum x, and is x smaller than the maximum x? Is y bigger than the minimum y? Is y smaller than the maximum y? If all 4 of those are true, it's inside the rectangle. Any other result, it's not. And so you can see if something's within a rectangle or a circle very, very easily. And then you don't have to do this more complicated option here, right? Where you're going to do a cross product. Okay. Which you are not doing. So what you need to do is not brute force. What you need to do is this. So if it's outside the bounding circle, then you can just reject it. Done. If it's within the bounding circle, now what you need to do is say it's within the bounding circle. So now what you need to do is say do a cross product. So you got a point. You want to know if that point is to the right of every line in your hole. If it's to the right of every line in your hole, then it is inside of your hole. That's what it. That's why we're going through this rigmarole with like cross product. It's like, you know, if cross product of hole dot at I hole dot start hole dot at I end. So that is the line on the hole that we're currently looking at from I to J, basically. So we've pulled out for every line in the hole. There's 2 points, the start and the end. Now we're going to dot product the point that we're looking at because they just entered a coordinate. We need to see if that spot is to the right of us or to the left of us. And so we have the line, and now we're going to see if V, you don't need point V declared out here. Yikes, what just happened there? Okay. So that's a point there named V. Okay. And so if the cross product of this is less than, actually let's say if it's greater than 0.
It has to be cross product 2 if you're going to use the third argument.
Why?
Because that's the... Oh, maybe that's just someone else's code. I don't know, somebody showed me that you posted a different one that automatically made a...
Yeah,
okay.
Remember what we talked about in class?
Overloaded.
You can overload it, yeah. You can have one version.
Yeah, no, because somebody that I worked with didn't overload it. So I thought you had named it cross product 2.
Nope. I called it cross product. Prado did change the name of it originally, and I told him not to.
I see.
So if the cross product's greater than 0, that means it's to the left, and we can immediately end this rigmarole, right? If we find, so we've got a point and we've got all these lines in the hole, right? And if the point that we're testing is to the left of any of them, we immediately know it's outside of the hole. And so we will see out point is inside the bounding circle, but outside the hole. Yep. And then we will just bool coolio equals true. And then we'll just note that coolio, we'll just do it this way. So if any of the people are to the left, we say, no, it's not cool, and we break. And we say if coolio see out point is inside the hole, else point is inside the bounding circle but outside the hole. And that's the code. So that was 20 minutes to write or something. 1 1 2 2 1 3 0 1 0 0. So there's the hole, and the bounding circle is still wrong because you're not finding the maximum distance between 2 points. You're finding the line that has the longest length on it, which is not the same thing. But whatever. All right. So let's see if 1.5 is good. It's inside the hole. Good. What about 0 1 to 1 1? Okay. So let's say 0.1, 0.1. It's outside the bounding circle. Okay. 0.5, 0.5. 1, 1. 0.9, 0.9. 1, 3.1. So, yeah. So Prado, you'll need to find the two furthest apart points, but that's the gist of it. Okay. So let's stop our discussion of Hull there. I'll give you guys till midnight tonight to finish it. I'll run the input tester at midnight. Okay. Hopefully that was an interesting assignment for you guys. There's a lot of uses for holes, and it's not just in computational geometry. If you get into like linear programming and optimization and things like that, there's a lot of problems that actually map into the hole problem, and having overlapping sets of half planes and stuff like that. Yeah, go on.
What if our holes are counterclockwise?
As long as you pass the test cases, I don't care.
Well, you can't pass the test cases if they're counterclockwise.
Well,
or at least not the parts where you print out, because your lines are going to be using different points.
Yeah, but I mean, if you're going to be saying it's inside or outside, then I don't care.
Yeah, those pass.
I'm fine with it. Can you look at Walker and eyes later then? Sure. Yeah, I'll help you guys with that. I do have a Japanese quiz due at midnight also, so I'm gonna be working too. Okay, so that's that, and this approach of, like I said, what a hole is a convex polygon, right? So a convex polygon is a polygon in which you can't draw a line outside of the polygon by connecting its vertices, right? So if you go from one vertex to another in a non-convex polygon, it goes outside, right? Somewhere within. A convex polygon, if you go from one vertex to another, it's always going to be inside of the polygon. That's one way of thinking of a convex polygon. And there's a lot of problems in computational geometry that are limited to convex polygons, right? And if you have a concave polygon, then what happens a lot of times, they'll split it, right? You'll draw a line from here to here, and now you've got two convex polygons, right? So a lot of algorithms only work on convex polygons, right? Yeah, all diagonals are within its interior. Yeah, it's one of the ways you can define it. Or here, if a line, one of the things you can use in more advanced stuff is that that every line that intersects a polygon only touches it in 2 points max. Could be 0, could be 1, could be 2. So that's useful in a lot of algorithms as well. Concave polygons look more interesting though, right? But you can always split a concave polygon into you can do triangulation or other approaches to split it into convex polygons. Okay, so the next big topic we're going to talk about is edge detection. So edge detection is used in a lot of applications as well. Again, we're talking about gaming. We're in IS-50B, but a lot of these things you're learning are actually going to be useful in a lot of different systems. Edge detection is used in computer vision a lot. So you can see, look, here's a girl with a flower. And then this is probably a Photoshop filter or something. That basically what it's doing, it's looking at it's running a derivative basically of the color or the brightness, if you want to think of it that way. And sometimes it runs horizontally, so it takes the derivative of changes in brightness horizontally. Sometimes you do it vertically. Sometimes you combine both. Wavelet transforms do a difference horizontally and vertically and both. And then so what a wavelet transform does is it cuts this image into a quarter. The top left corner becomes a low res version of the image. The bottom left corner is like the horizontal derivative. The top right is the vertical derivative, and the bottom right is the horizontal and diagonal derivative, basically. and then the process repeats. And so, wavelet image transform. And so I was hired to port a wavelet codec from C++ into C. And goodness. Yeah, so you can see the original image. That's no, that's not Neuschwanstein, is it? Maybe it is. No, Castle. No, that's Castle Liechtenstein. Yeah, I know my castles. That's Liechtenstein Castle. Boom, boom. All right. So here. And so basically, this is a derivative one way. Let's see, this would be probably horizontal then. This one, I said it backwards, but who cares? So this is the horizontal derivative. So you can see, like, anytime there's a change in brightness, see how there's like an edge there? There's a change in brightness, and so that will show up as a line, right? And so the brightness here is the change in, it's the change in brightness horizontally. This is the change in brightness vertically. So you can see all these horizontal lines here. Because what you do is you go down the pixels, and if it goes from 200 to 255, that's a change of 55. If it goes from 0 to 100, that's a change of 100. And so you can see all the horizontal lines get picked up on this one, all the vertical lines get picked up on this one, and then this one is like the residual. It's the residual. So basically, you take the original image and you subtract these things out, and you get this. So you can reconstruct the original image from it. And so what's neat about wavelets is that they're used for like image compression, right? That sounds too simple. It sounds too simple. Yeah, right? I mean, yeah. So what you can do is, what's nice about this is that, let's say this is stored on a web server. You can actually stream this section of the image to somebody, and they will get a quick preview of the image, right? And you can actually repeat this process over and over again as many times you want. And you can actually fill in, you can just send them the low-res thumbnail, because it basically comes with its own thumbnail. It's like progressive JPEG. Progressive JPEG has multiple different resolutions of JPEG built into it. Like, so normally when you're loading an image, it kind of scrolls downwards like this. But with a progressive JPEG, it starts off low res, then higher res, then higher res, then higher res. And so with wavelets, you kind of get that ability baked in. But what's neat is that you can actually, you don't even have to send the whole thing to somebody, because with the image data and the edge data, you can oftentimes reconstruct a nice looking full-sized image, because the edges are actually where the features are. The edges are what the human eye detects, right? If test here, and so if you were to zoom in on this, right, there's very little variance in the color here, right? And so the human eye basically kind of discards most of that. Like, very little of this is actually important, but the edges are super important, and that's something that JPEG gets RONG wrong. Right? Have you guys ever seen this before? Deep fried memes, yeah. And so wavelet image compression is better than JPEG. Honestly, there's been no really good reason to use JPEG for 20 years. But, you know, people stick with what they know, I guess. I guess you can make, I don't know. There's really no good reason for it. But JPEG, anytime there's an edge, the JPEG will start ringing. And the reason for that is because JPEG uses what's called a discrete cosine transform. So what JPEG tries to do is that it tries to match a cosine wave to fit the fluctuations of brightness in the color. And so, can we zoom in? download. Open? Did it open? Did not open. Okay, here we go. Oh, we found it. Yeah. So here's a wavelet transform of Lena, which is one of the most famous images used in image processing. So you can see it keeps going, right? So down here, the very top left corner, you can see there's the actual picture. And then what you can do is, when you transmit to people, you can send the data like this. From the top left to the bottom right. The bottom right is the least important data. The top left is the most important data. And so you can actually transmit the data kind of like that, from the top left to the bottom right, and it will fill in. Or what you can do is you can just discard, like all this data here, you can just discard it. And you'll still get a pretty good image reconstruction. Okay, so what Jpeg does is it takes a chunk of pixels, it breaks it, it's called Discrete Cosine Transform, DCT. What it does, it'll break it into a block of pixels, and what it does is it tries to find a cosine wave of brightness and color that matches the pixels most exactly. And cosine, as you guys are aware, is a non-spatially bounded function, right? A cosine wave will cosine itself forever. So they limit it by having a block size of, you know, this big or something. But even still, every time you have a sharp edge in a JPEG artifact, every time you have a sharp edge on something, it will ring, because you can't model a discontinuity using a cosine, right? And so anytime there's an edge, you'll get this ringing effect where the colors will teleport outside the edge, because you got a lot of red here, so it's got a big magnitude there, and then there's an edge, so it tries to match the edge on the downside, but then it comes back up, and that's why you see a space and then the color appearing on the back end of it. And it's and that's why JPEG artifacts are so famous for being bad, right? Because if you're trying to read a font, right, like we read fonts by doing edge detection, right, and you get all, like, it just right, here's the M, right, you can see the ringing effect, right, it's a cosine. And so there's a straight line here, and then you get bad, you know, artifact lines on that side. You can see them here. You can see the dots around the circle. And so it's just the result of how JPEG works, really. And so you have to use more pixels, or more bits, right? So if you want your JPEG to look good, you have to throw more and more bits at it to get more and more accurate representations, and at a certain point you're not really saving much size at all. If you do lossless JPEG, you can get some gains, but at the beginning of each player's draw step, that player draws 2 additional cards. That's pretty cool. Is that a real card? That's pretty cool. I like that. I don't know why it's showing up on JPEG artifacts. Oh, it is an artifact. Different kind of artifact. Anyhow, so wavelets, what they do is they do edge detection, right? It's just edge detection, and all it is, it's to do the derivative. It's just a difference from one pixel to the next. Like, it sounds like all this stuff, and if you look at like the literature on it, it's super complicated, right? Wavelet, math, and you know, it's like I don't know, like, you know, these things look, horizontal, vertical, diagonal edges, and you know, these things look like, man, these things are really complicated, but it's really easy to take a differential of brightness, right? It's just the brightness of one pixel minus the brightness of the one next to it. Done, right? And so that's what you guys are going to be doing for Edgelord, your next homework assignment. It's just you're going to be taking a vertical differential and a horizontal differential. And it's even easier than that because there's no actual color data. We're going to be going back to the Roni Kingdoms assignment that we did 2 assignments ago.
That's a nice cathedral.
And this is a castle, girl. This is Liechtenstein Castle. And it's pretty famous. That's why I recognized it. It's one of the most photographed castles. Look at that. It's like on a little... Look, it's on a little rock spire. And then there's a bridge that comes this way out of it.
That's a nice castle.
Yeah, and then there's the one in... Castle Prejama. Just, you know, this has nothing to do with anything, but it's important you know it. Right? So, Ada, look at this one. It's a castle built into a cave. And that's literally what the castle name means. It's literally a castle built partly into a cave or something like that. So, this will be on test 4. This will be on your final. Yeah, we're going to have a test of famous castles. Okay, so... So yeah, so the you know, horizontal difference, vertical difference. So what I'm teaching you guys, I'm teaching you stuff. Yeah, it's related to games, and you're going to see how it's related to games in a little bit. But I'm trying to show you like computer vision stuff, image compression. There's a lot of uses for these techniques that I'm teaching you guys, and that's why I've been kind of thinking about what topics I want to get into, because it's like, you know, what if you get a job working for an autonomous, you know, automobile company, right? Like being able to do feature detection is really important, and feature detection, computer vision usually revolves around. Well, there's a lot of different ways of doing it, but you know, there's a line here, there's a line here, and what the human eye does when we see something like that. Do you guys see how you can see the castle, right? All the color data is gone. All the color data is gone. There's no color at all. It's black and white. But you can still, like, I still recognize the castle from that, because that's how human vision works. The brains will actually split images into lines and combine the lines into shapes and recognize the combinations of shapes. And so like a stop sign is a combination of, you know, the different lines in the whole, right, that make up the stop sign, and we recognize that combination as a stop sign. And so edges are the most important thing in an image. The pixel data is actually a lot less important than the Jpeg people thought, right? The Jpeg people wanted to approximate the color changes over time, and the wavelet people are like, no, what matters are the edges. And so wavelets can give you a sharp edge, and the Jpeg people work better with, I don't know, pictures of water, I don't know, something like that. Anything that doesn't have a sharp edge in it, like the Jpeg, might be better. But for the human, because human vision is edge-based, like wavelets work really, really well. And so my job was to port wavelet code from C++ into C. It was a fun summer project I got paid for. And yeah, and if you discard the bigger parts of it, then you've got compression. So you can just discard the big ones, and you can reconstruct the full-sized image by extrapolating from where the edges are, right? So rather than having it get all muddy and stuff, if you know where the edges are, you can draw a nice clean line there, and the fact that the fill in the blank stuff in the middle is a little muddy isn't nearly as important as the fact you got nice sharp edges. It's almost like a vector art, right? Yeah, like this kind of stuff where they draw the edges, right? The edges that matter, not the stuff on the inside. And so with vectors, you'll get nice crisp edges, and then the stuff on the inside might lose some color detail, but looks pretty nice. It's nice and crisp. Okay, so edge detection. So in video games, yeah, actually this will be good. So in video games, it's very common to want to know where edges are in video games for a variety of reasons. One very common use of, so you can do cell shading. That's one thing. So if you guys have ever seen like Okami, let's see if we can get a picture of it. Yeah, so in Okami, this is actually a 3D video game that looks like it's a 2D painted Japanese artwork. And so what they do is they do edge detection to locate where the edges are, and then they fill in the areas in between with color, right? And they'll shade it a little bit so you can kind of see the 3D-ness of it. But basically the game finds where all the edges are, and it paints it in using like a black ink, basically. And it's a really fantastic effect, even though it's a older game, like the game just looks, you know, really, really fantastic, and it's a really neat effect. Or Wind Waker. So Wind Waker is cell shaded, right? So, but what I was thinking about was in video games where you got this kind of stuff going on. A lot of times you'll just highlight the edges just so that the players have a more clear view of where things are. It's kind of common in like first-person shooters to put edges around the enemy players and things like that so you can see them better. So they pop out from the background. So you might draw like a very subtle yellow line around enemies so that they stand out of the background. You can see them and shoot them, because when you're in a chaotic video game and there's explosions going on, it's possible to just lose sight of what you're looking at. And Path of Exile has this problem in spades. The game is incredibly spammy, and it'll put so many visual artifacts on the screen that a lot of times you'll die just because you can't see what's going on. I actually once played a build that generated so much spam on the screen that I would just die, and I'm like, I have no idea what killed me. I don't even know if there was a monster on the screen or what. I couldn't see anything. It was just, there's just bullets everywhere, basically. Like, why did I die? I don't know. And so with that build, I actually I actually rebuilt it so that my character would curse everybody within, like, you know, the screen. Not because the curse was that important. It was nice. It boosted my damage a little bit. But because when the enemies were cursed, it put a floating icon above their head, so I could actually see where the damn enemies were. Because otherwise, it was just like, you know, fire, just spinning flames, and I think that one was a trap build. And so I had flamethrower traps that were just shooting these giant spirals of fire, and there's lightning bolts flying in every direction. And I actually took a curse just so it would highlight where the enemies were on the map, because I had no idea. Marvel versus Capcom, does that do cell shading? Okay, yeah. All right. Yeah, it's a nice effect. It gives you like a comic book effect. But kind of what I was getting at is that when you know where edges are, you can actually enhance them. You can zoom and enhance, right? And actually draw the edges in on the boxes or walls or whatever. And that makes things pop out more. But usually I would use it personally on like enemies that you need to see. Because if there's no contrast, the human eye has trouble picking it up, and dying from things you can't see is a really bad feel. It doesn't feel good. Unless your game is based on stealth or something like that, then okay. Yeah, I'm just talking about finding the edges right here, right? Okay, so there's all sorts of free self shaders and things like that. Yeah, that's nice. Yeah, Revenge of the Obra Dinn. I had a friend that was like really into that. Yeah. Okay. So that's edge detection. Used in a lot of cases. Yeah. The algorithm's pretty simple. Borderlands doesn't use cell shading. Really? I thought Borderlands was cell shaded.
It's because a lot of people think that the cell shading's the black outline, but that's not what it is. It's it has to do with the way the light interacts with the surface. It doesn't have to do with the black outline.
Yeah, the cell shading is the inside of the polygons, and it's usually a flat. It adds like a flat lighting or like a two-tone lighting.
If you look at exactly, the two-tone look. Like if you look at Wind Waker, like that's cell shading.
Yeah. But what I'm talking about for your next assignment is the edge, like finding that edge. And drawing like an edge on things, because that makes them pop, right? Do you see how there's like a black line right there going around her? that causes her to stand out from the background. And in this case, she'd probably stand out anyway because she's in front of the sky or whatever. But when you have same color on same color, it could be hard to see. Like this, for example, right? Same color on same color. Without that black outline, that gun would probably melt into the background and you wouldn't be able to see it. Now it's your gun, you know it's there. But like if that was an enemy, then and it kills you, you'd just be like, all right, that's horrible. And Path of Exile punishes you for dying too, right? That's actually the reason why I stopped playing Path of Exile. Was not because the game was too hard or any of that stuff, but because most of the times when I died, not always, but most of the times when I died, it was from something I literally couldn't see on the screen. And it's just like, okay, cool, that was fun. And it's like, there goes 3 hours of my life. I was grinding up a level, and I died due to a monster that I couldn't see. I just lost all of my progress for the last 3 hours. Yeah, I'm uninstalling, right? So, yeah, I haven't played the last couple expansions of Path of Exile. And I really like the game. Like, I think Path of Exile really is like the best action RPG out there. But there's some frustrations in the game, like the lack of an auction house, the lack of a death message, the visual garbage spam on the screen that makes it impossible to see anything. Like, some of the encounters are just like,
Weird.
not weird, but like Path Exile, was it Brine King? They're just designed to be just visually like impossible to see what's going on. Like, look at this. And so the thing is spawning. The thing spawns areas that if you stand on them, you die, right? Or take a lot of damage. And so the trouble is, like, oh, see, he almost died right there.
You used to play a lot of you play a lot of games.
A lot of this. And so the battlefield has the waves periodically come in very tight and then back off. And it does that like 3 times. And so here's the thing: if there's so much spam on the screen, you can't see those markers, and it draws the guy's 3D shape over it, right? And the battlefield constricts to be this big. So you just got hit, and it takes off like 2/3 of his life.
Well, he heals really fast. It looks like.
Yeah. And so if you're playing a spam build, it covers up those markers on the ground where you can't stand, and then you die, and you're just like, oh, that was fun. And if you're playing in hardcore mode, where you can die once, that's a sin. And if you're playing in hardcore mode, you know, and you can't see these markers where the lightning's going to appear, it's like
game over.
Yeah, you can't even back off and let your friends kill it, because if you party up with people, the battleground becomes this big anyway, and it puts you into like spitting distance of each other, and then it draws things on the ground you can't see.
And you can't move.
You can move in about this big an area, and so if you're playing a build that isn't spammy, you can barely see things enough to dodge out of the way of them. But if you're playing any sort of spam build, like it's just poor visual design. Honestly, is all it comes down to. It's just. The compressions make it even harder to see. Sorry. Do you want to call your friend?
Can I call Kimura?
Yeah, go for it. Here.
Can you call Kimura?
Yeah, go for it.
On Facebook?
Go for it. So yeah, it's yeah, the compression doesn't help, but basically dying because a game has poor visual direction is super frustrating. It's like dying due to lag, right? If you're playing a game perfectly and the game lags out and you get killed, it's just frustrating. It's a lot more frustrating to die due to lag than it is due to, you know, somebody backstabbing you or something like that. So, how visually spammy it is. Yeah, that guy wasn't even playing a very spammy build. Like, my builds would flood the screen with death, you know, and that was just a guy with one little ability, you know? And it's fun. I mean, it's fun to flood the screen with death, but like, if you can't see anything, it's like, I mean, well, maybe you shouldn't play a spammy build. Well, you know, maybe you should have better visual direction. I don't know. Joke's on you. I'm not playing anymore. Okay, so we're going to do the next thing is called Edgelord. And so this is going to be teaching you guys a very simple edge detection algorithm. So if you guys remember the Veroni regions, if you guys remember Veroni kingdoms, right, where it randomly generates a map, Mr. Walker's had a... is Walker not here? What happened to him? Mr. Walker's had, you know, the Warhammer kingdoms in it or whatever. So he's asleep. Yeah, that's fair. I feel like being asleep too. And so what you can see here is that the edges, anytime there's a two edges that are vertical, that are like next to each other, it draws a vertical line. Anytime there's two edges that are above each other, it draws a horizontal line. And any place where it's both, it draws a plus. And I encourage you guys to do better than that. There's an extra credit point available if you use the Unicode characters for drawing boxes. There's actually all sorts of symbols used for corners and diagonals and boxes and things like that. You can make it look a lot better. The colors of the region are still there, but they're only drawn on the edges. Okay, so only on the edges. And it still has the Veroni relaxation, so we do that. We do a relaxation. And then after that, what you can do is you can have one country conquer another. So I click on green, and then I click on tan, and you see that? It floods, it conquers that country. And I can click here, and so I can create concave countries. Okay? So this would not normally be, Veroni regions are, I think, guaranteed to be convex polygons. But by using this map, you can merge together adjacent cells and create much more interesting maps, right? And so, yeah, with mouse support. And so, and technically, I guess they don't need to be adjacent. I didn't actually think of that. You can actually conquer remote countries as well. But, yeah, so this country and this country are the same. There we go. And so when I conquered this one, the boundary here went down and the boundary here went down. So you can have very interesting country shapes. And that's actually something that you might want to use also when you're doing random map generation and things like that, because just having convex polygons is kind of boring, right? And so Veronis are good for making cobblestones and things like that, kind of a semi-random tiled cobblestone pattern. But if you're trying to make like countries and things like that, then you can merge adjacent Veroni regions together and create very interesting shapes like this, right? Like I'm sure you guys can see, you know, that this, you know, let's just conquer the whole world, right? You can conquer the world. There we go. Okay. But you can make, you know, if you start off by doing a Veroni and then start merging random cells together, you can actually create quite interesting shapes and patterns and things like that. And so for this assignment, you're going to do edge detection, and then you're going to do conquest mode. Conquest mode is just you click on one region, you click on another region, and you merge them together. Okay. So it's not too bad. This took me a couple hours to do, I think. An hour, maybe. I don't know. I was talking to Walker in Harlem last night. So that's about it. So yeah, edge detection, and then mouse support in the terminal. What else? To conquer neighboring kingdoms, and then there's something I didn't do yet because it was late and I was tired, and I had to be up for a 8 o'clock meeting today that I ended up feeling too sick to go to. You don't think Unicode would work well with this? At least the certain boundary shapes? Yeah, I don't know. Try it out. See how it works. You can give it a shot. Putty's support for Unicode's not great, so we'll see. See how it goes. You can try the it's called extended ASCII, which isn't exactly an accurate term because there's many different kinds of extended ASCII. But there's a variety of 8-bit ASCII encodings that have vertical lines that actually touch each other. And if you've ever seen this in like in curses, they'll draw windows with lines and things like that. That's usually using one of the 8-bit ASCII encoding patterns. Yeah, and so the third thing you need to do is whatever the country name is, you're going to need to tag that region with the full country name. So not just the letter, right? Not just I for Indianapolis, but you need to give the country of Indianapolis. which is one of my countries. There's Prague and Indianapolis. I was thinking of it kind of like as Civ 6, you know, where like there's like city-states, you know, things like that. Does it break if you click two countries that aren't touching? No. It'll actually support it just fine. So this country can conquer this country. This country can conquer this country, and it changes all of them. So to tag the region properly. In other words, to print the full name of Prague or the full name of Indianapolis, but with a caveat that you need to find a spot that can hold the whole name. Like there's not enough room here to do Indianapolis, right? Like you can't print Indianapolis here. It's not big enough. So you have to find a spot within the region where you can print the name Indianapolis. You have to find the spot closest to the center of the region that has enough room for Indianapolis in it. So this is a very interesting problem. If you ever look at Europa Universalis 4, their tagging code is garbage. Garbage. It doesn't sound complicated. It's really not. I mean, I haven't done it yet, but I'm sure it's easy. So that's in the Edgelord directory. The other ones were too easy. I thought the other ones were too easy. Okay, U for bad tag. Let's see. Yeah. So in Europa Universalis, it'll put a tag over. You know, there's an algorithm they use to try to figure out where these names should go, and sometimes they get drunk and go home. You know. Fur factory. That's funny. All right, all these are pretty fine. One tag conquest of Ryukyu. It's pretty impressive. I don't know what this is. Yeah, sometimes it'll make really weird tags. Sometimes the name will actually curve up on itself, so it'll be like Spain, and it got stuck in like one corner of Spain. It's like Spain, like that. So I'm not expecting you guys to do optimal, like whatever. Just find a spot near the center. You don't have to worry about center printing it or anything like that. Just find a spot near the center that you can print the full name of the country, and that'll make it a little bit more immersive. The other cities, I guess you can delete them. I was kind of leaving them on my map because I was kind of thinking about, all right, Civ 6, so you have these city-states that are one city countries, but then when they get conquered, they're still there, right? So I was kind of thinking about it in those terms, like you have the country of Indianapolis, then it can conquer other cities on the map. And so maybe the I would still be on the map for Indianapolis, but then I would just put a tag on the nearest open spot. Okay. You think it's hard? It's not really that hard. Just start, you already have code that finds the center of the map, right? The center of a country. You already have code to do that, right? The Centroid code that you wrote for Veroni 2. The Lloyd's relaxation, you already got it done. And so all you need to do is start at that point and see if there's room to the right, or you can, if you're center printing, go half to the left and then see if there's room half to the right of open tiles. If there are, then print Indianapolis over it. And if there's not room, then you go one north, one south, one east, one west. Repeat. Recursive. Yep. Check in each direction. Leave a breadcrumb behind so you don't recurse forever. Oh, this spot's not available. Leave a note. Make an array or something. This spot's no good. And then recurse to the north, recurse to the south, recurse to the east, recurse to the west. They'll check to see if that spot's available. If they're not, recurse again. And it will just spread outwards, breadth first search in every direction. First one to find it is done. Cancel all the other iterations, which should be automatic, basically. And then print the string You don't even have to write it into the map. You can actually see out it. You can the library that I give you guys has the ability to move the cursor around. So you just move the cursor to let me go back into the server. You can actually just write. You can write the name of the country over the top of the rest of it. Okay. So if we go into Edgelord, so I've given you guys some example code that has basically a good starting point for you guys. I think you guys ought to use your code, but if your code doesn't work, then you can use my code. And it's a pretty good starting point. There's some tricks, there's some C++y stuff in there that you might like. Good C++ tricks. Okay. So this here is a structured binding right here. So that is going to grab two variables from one function. So the function is returning two variables. It's returning the number of rows, the number of columns. And so you can return two things at once using structured bindings like that. It's technically splitting apart a struct is what's happening. Let's see what else. Okay, yeah, so the example code also has code to handle mouse input. So if you guys have never done mouse input using my library before, well, why would you, right? There's code in here under Part 2 Conquest that will show you guys how you can accept mouse events in PuTTY. Okay, so raw mode on is used for non-blocking I/O. So that allows you to read arrow keys, page up, page down, all that stuff that you miss, when you're doing console programming. Console programming normally takes place in what's called cooked mode. Cooked mode, CN doesn't give you any input until the user hits return, until the user hits enter. And in the meantime, the user can type in things and erase things and type in things and erase things. Your program does not see it. Raw mode, you will see every keystroke the user gives you. It will give you one keystroke at a time. And this is very useful for games and things like that. And we'll probably be using this when we make Doom inside of the console, if we get around to that. So you can use arrow keys or WASD to immediately, move around inside the world. I always wondered, how do you do more than one input? You just keep read. You just call quick read, and quick read will tell you the next key that's been hit, and there you go. So. How do you do more than one input at a time? I don't know. This code here returns one key on the keyboard that's being hit currently. Okay, so raw mode on true turns on immediate input, so you can use arrow keys and things like that. It's pretty cool. Mouse mode on turns on, being able to click on the screen. On mouse down is a callback. So like you guys probably remember from CSI 50, IS50A, is that games are oftentimes event driven. And so what this is an event handler. And so by default, when you click the mouse, nothing happens, right? So with this, what you say is that when the user clicks the mouse, call this function. Okay. And this function is located in a little header file I made called quick read. And so mouse handler here, all it does is set some globals to the last row and the last column the user clicked on. So mouse handler, all it does is it just sets some globals and does nothing else. These functions here clean up your code. If your code dies when you've set the font color to black, you're in trouble, right? Because the font color doesn't get set back, right? And so I've got a function that resets the colors and clears the screen and all that other stuff. And I also made it so that when you hit Control-C, rather than killing the program and not resetting the console, it just calls exit instead. Exit will call bailout. Exit will call bailout. Why? How does it know to call bailout? Well, I'm glad you asked. This is a great question. Thank you for asking it. There is a function in the C library. There's a function in the C library called @exit. And what that means is that when the program quits, call this function. And this is really useful when you're doing things like what we are, because what we're doing is messing with the font colors. And if you mess with the font colors, you can end up with your console with the font color foreground and background both set to black, which is not what anyone wants. So this guarantees that no matter how the program quits, it will call the bailout function. The bailout function clears the screen, resets the font colors, etc., etc. Okay, and you can make your own bailout function, and that's like if you want to make sure that a socket gets closed or something like that. That's oftentimes what it's used for. Like if you're in a video game and the program quits, you can register a function to run on exit, and then you can like close your, hey, send a message to the server, hey, I'm disconnecting right now. And so the server isn't just like waiting there with an open socket, like, what happened, man? So if you quit, then it's you register a callback basically, and when you quit the program, it calls that function before it quits. Very useful stuff. So main is not the beginning of your program. Start is. Start calls main runs, and then when main terminates, all the add exit functions run, right? So there's cleanup stuff that happens after main. And so when you call exit, the C function exit to quit, it's not quitting. When you call exit, it jumps to the exit section and runs the code there. So if you actually want to quit immediately without calling any of these add exit functions, there's a different function you can do for that, which I never use. But there is one. I don't remember the name of it. Terminate, maybe? And exit. All functions register with add exit and on exit are called in reverse order that they were registered. Underscore exit. Yeah, that sounds right. So the underscore exit function actually quits your program. Doesn't call any of that stuff. None of that fancy on exit, add exit stuff. Nope. Underscore exit will die your program immediately. It's dead. It doesn't clean up anything. So, yeah. All right, seamlessly. So, yeah. What else we got here? So on mouse down, this basically says when the mouse is clicked, call that function. And so the upshot of that is that you can read rows and columns, the last, what is it called? Last row and last column. There are a couple of globals that get set by the user clicking. And so quick read is when it will accept a mouse event. This is actually where the mouse event comes from. And yeah, so basically it's going to sit there and spin, sleeping 10,000 microseconds at a time. Spin, spin, spin. If they type Q, it just quits the program. Otherwise, when they click, last row will get set, last column will get set. It moves the cursor to that row and column. It draws an X there. That X draws on top of the map. You can use this trick to draw your tags on top of the region of the map. And flush will make sure the screen updates. Do the same for the defending province, and then you can see who the owner is of one province, who the owner is of the other province. If they're the same person, continue. Otherwise, what you're going to do is go through the whole array and change the ownership of every tile of the defender to the attacker. So the attacker always wins. Right? So you're just going to go through and change the ownership of every tile, and that's it. That's all you got to do. So there's only two things you have to do really for this assignment. The first is to modify the print. All you have to do is modify the print world function so that you only print the edges. Simple way to figure out how to do that is that if your neighbor in all four directions is the same owner as you, just print a black square, man. That's it. That's the easiest way of doing edges. If the person to your north, the person to the south, the person to the west, the person to the east, same as you, you're not an edge. You're not edgy enough. So, print a black space. Right? So the background color to 0, print a space, and you'll print, that's it. And then in areas where there are edges, if there is a difference in color to the east or west, then you draw a vertical slash. If there's a difference in color to the north or south, you draw a horizontal slash. And if it's both, then you draw a plus. That's it. So the print world function, you should be able to hack that together in short order. It's much easier than whole, I think, finding an edge. And then down here, I've already done the code. I've given you sample code that shows you how to do mouse events and things like that. So you don't have to read through my documentation to figure that out. Okay. All you really need to do here is write a for loop that changes all the owners of one tile to another. That's it. That's the assignment, basically. Okay. So, what do you think, Carl? Do you like it? Do you like edge detection, Ada? What do you think? You don't like it? What if I showed you? What if I showed you can conquer different countries with the mouse? With the mouse.
It's cool, not the coolest.
Not the coolest.
Well, it's cool, but like, it seems cool, but I think I'd maybe rather play Sheepy.
Tell me.
What's with all the letters?
Those are all the different cities in the world. So when it starts off,
there's not a lot of cities.
When it starts off, yeah, there's like a dozen cities or so. You can add more. Walker had like a bunch. So it starts off, it randomly generates a map, and basically all the provinces you own are those that are closer to you than to the other people. And then you can even them up a little bit, and eventually they'll turn into very even things. And then you can join them together in unholy matrimony.
Can I call him?
Go for it. Alright, so that's your assignment, guys. Walker had 80. Yeah, he had 33. Alright, dudes. So I hope this is interesting for you. We'll start doing more Unreal Engine stuff in a bit, but I've been kind of really wanting to teach these kinds of topics for a while now. I haven't had the class for it yet, so the programs I don't think are hard so much as just like you got to wrap your mind around the concept of it. So, but you know, my take on it is like once you understand the concept, then the programming should be fairly easy, and then you can take those concepts elsewhere. Like if you go into finance or you go into business and you need to optimize factory production using the powers of linear algebra. The whole computation model is actually used for that, right? Like it's just these things we're learning. I'm picking things that are deliberately like useful in a lot of contexts and things like that. So
for some reason, calls aren't working.
Calls aren't working. Okay. Anyway, I'll talk to you guys later. I need to message Nico about the laptops. Yeah, I need him to get the CSI 45 stuff out of here because my house is covered in boxes from last year's CSI 45. And I would like to have my house back. It's been a year. All right. See you guys. Good luck. Have fun. Ada Wave.
In that game, you know, they allowed me to like mess with it and like create